70 degree to 80 degree. That is a type of low baking enamel. And normally moderate baking, that is around 100 to 120 degree. There are some high baking like about 200 degree. And there are some heat resistance paints also. And in fact, that is they get dried by the, that is a performance. For instance, these paints can be applied on the that is the heat engine part also, that is the exterior part. And catalyst curing paints. So here the paint is dried by combination of the hardener and finish. You would have heard about these epoxy finishes and polyurethane finishes. So they are after all made up of two components or three components depending on the type of system. By mixing properly in the given ratio, we can attain the drying and better performance. Now let us go back to the resin system. So we have got different types of resins like alkyd based resins, NC based resins, nitrocellulose, then acrylic lacquers, acrylated alkyd, then stowing enamels that is melamine based, urea formaldehyde, melamine formaldehyde, etc. And we have got some thermosetting acrylics also, then epoxy and polyester, finally polyurethane. And we have got water based dispersions like polyurethane dispersions. They are called the latest PUDs, PUDS, polyurethane dispersions. Okay. Then now let us talk about the machineries required for making any paint. Normally we that is a need a mixer and ball mill. It will be a cylindrical one. By cascading the, that is a ball, that is steel balls and pebbles are available. These are all the different types of grinding media. Based on the type of paint, that is this kind of coatings are given. And that is filling machines. So once the paint is ground, it has to be properly made up. So we have got various types of mixing tanks, and followed by that, and even when we talk about the grinding media, there are so many types of grinding media available. Then attritor is a very good machine required for making any kind of paint. Then pug mill is designed for putty paints. Then after making all these paints, we had to fill up suitably with some sealing arrangements. So we have got filling machine, packing machine, and we should have some heating ovens, and any paint industry should have some small laboratory setup. Then we can have the major raw materials like these are all only categories under which we have got enormous types of raw materials in any paint. For example, pigments. It can be white pigment, colored pigment, and basically white pigments are titanium dioxide, rutile, and anatase. So titanium dioxide anatase paints are very much used as a cheap paint or wall paints, whereas titanium rutile, it has got better opacity, hiding power, and they are used in superior enamels. And we have got other colored pigments based on chromates also. Now let us move on to extender. Extender is nothing but a false pigment. Okay, so it means it just fills up the surface, that's all. It acts as a surface filler. That is, it can reduce the cost. And in fact, that is in primers and surfaces and putty paints, that is, we are using these extenders very much. Then that is a varnish and resins. So we have got various types of resins. Then solvents, petrochemical solvents, they are the major solvents, and then additives. So when we talk about additives, we have got special additives. Additives are the chemicals which are added in very small quantity so that it will serve the particular purpose. For example, if you want to make a yard drying enamel, we need some dryers. For example, there are so many types of dryers available. We call it primary dryer, secondary dryer. So these are all octavates of some metals like lead. So lead octavate, then that is manganese octavate, cobalt octavate. So these are all the different types of dryers. So similarly, there are so many additives. For example, paint have the tendency to undergo skinning, that is there will be some dried layer formation at the top. So in order to avoid that, we have got some anti-skinning agent also. So likewise, we have got so many additives. And then now let us look at the customers who are very keen on this paint manufacturing, paint products. For example, we have got the domestic product like civil constructions, architects, then we have got carpenters, then monuments, malls, amusement parks, religious places like temple, mosques, churches, then swimming pools. All these people are in great demand of paint. They are in great requirement. So you cannot simply avoid any paint, because paint and cement, these are the two fundamental materials in modern world. So anyone who has invested money in manufacturing will definitely get huge benefits, and they cannot be losers in this market, provided they operate it in a very systematic manner under proper technical guidance with sincerity. Then industrial markets. So we have got automotive industries, plastic manufacturers, component manufacturers, container industries, engineering industries, chemical industries, electronic equipment manufacturers, even there are so many manufacturing units. These are all OEM people. They are badly in need of very good quality paints. Then technical know-how. So we have got the technical know-how for nano coatings. When I say nano coatings, it is used for undercoating, that is a metal pre-treatment, where we call it nano ceramic coatings. So recently we have done some researches and come out successfully with a patent at University of Madras. You can contact us, and with the University of Madras, we will be able to help you also. Then candy finishes, then texture finishes, hammer tone metallic finishes, matte finishes, heat resisting coatings. So these are all my personal researches and experience I have acquired by serving in many paint industries. Then flame retardant coatings and water repellent coatings. So our consultancy services are paint formulation, metal pre-treatment, chemical formulations. Then we undertake turnkey projects for nano coating and powder coating plants. Then troubleshooting is being done in surface coating. So in any OEM people, if they have some problems in finishes, that is surface coatings, they can very well approach us and get our expert opinions, so that they will be able to come out of the defective coatings, and they can standardize the specifications of the paints also. Then we undertake a project training for entrepreneurs, companies and research associates. So we give e-learning training, we give short-term certificate courses also. Then we undertake project training for research students, and if there is any doubt, we conduct doubt sessions through Telegram, and we regularly conduct live sessions in group, Google Meet, for individuals as well as for group of trainees. And we also undertake corporate training at their premises. So for everything, you can contact me in this phone number given, email address, and also kindly visit our website saitechinfo.com. Thank you very much for watching this video. Hi friends, welcome to this technical series on surface coatings. Here you can see some luminescent coating on the highways. This is very helpful for the day and night vision. Actually, this is the functional purpose of paint. So these are all called nowadays smart coatings. Now let me discuss about the overall purposes of paints. And before that, let us try to understand the ingredients of paint. Paint essentially consists of 4 important ingredients: pigment, resin, solvent, and some additives. Additives are small chemicals added in small quantities to serve certain purposes like enhancing the drying time or drying, or improving the adhesion, or providing the water resistance, then to avoid the skinning of paints, etc. Now let me focus on the pigment. This can be classified into two parts, that is true pigment and false pigment. True pigments, actually they are imparting colors. They offer colors. The coloring matter, which is nothing but some inorganic or organic materials. Whereas extenders, which are the false pigment, it is used just to fill up the surface. In fact, by incorporating this, you can reduce the cost also. But at the same time, extenders do not have hiding power, whereas true pigments have better hiding power. Because the purpose of painting, the purpose of coating a paint on a surface is to hide the surface, is it not? So the hiding power is very, very important as far as pigment is concerned. We have three values of a paint. One is aesthetic value, that is, it has got the decorative value. It is to enhance the beauty of a surface. Secondly, it acts as a protective coating that works against corrosion, weather, humidity, fouling, microbial attack, etc. And there is a third aspect about the paint, that is called the functional use of paint. It is used to serve a particular function. For example, as we already discussed in the introduction, the application of luminous paint on the highways, the tar road, where fluorescent or black and white paints are applied. Of course, they are applied on the trees on the sides of the highways also. It helps the driver for smooth traveling. And there is another type of paint called sound deadener. It reduces the vibration noise of a sheet metal component. Particularly, it is used in buses and trains. So they are called acoustic paints. So these are the functional uses of paint. Now, as I already explained, I have shown here some luminescent coatings, and you can find in some interior, that is indoor paintings also. Now, what are the major ingredients of paints? As I already discussed, pigment, that is the coloring powder, and extender, it is the false pigment. Then resin, that is the important component of the paint, which is nothing but the polymer or varnish. Then we have got some mixture of petrochemical solvents, alcoholic solvents, ketonic solvents, etc. And we have some additives. When we think of paint, that is, we are very much interested in colors, and pigments are responsible for imparting colors. They are the coloring matter. In fact, pigments can be broadly classified into inorganic and organic. Inorganic pigments are metal-based oxides, chlorides, sulfates, and some minerals, etc. There are some natural inorganic pigments, and they are inorganic minerals, we can say. And similarly, nowadays, variety of modern organic pigments have been tried also. Now, the pigments can be broadly classified into, as I already suggested, inorganic and organic, where we have got white in inorganic and colored in inorganic. In white, particularly, it gives more opacity, so it is called opaqueness. And titanium dioxide, zinc oxide, lithopone, zinc sulfide, they give better opaqueness, that is opacity, hiding power. There are some non-opaque, that is non-hiding pigments like calcium carbonate, talc, barium sulfate, mica, silica, clays, etc. They are all called as pseudo pigments or false pigments. They can also be called the extenders. By adding suitably, we can reduce the cost also, but without compromising on the hiding power and other important quality parameters of the finish. Now, let me come back to the colored one, colored inorganic pigments. They can be classified into natural and synthetic. Natural pigments are ochres. The yellow ochres are very popular. Umbras, then hematites and magnetites. And then we have variety of synthetic inorganic coatings. And we have got cobalt blue, cobalt green, iron browns, and we have got some rutile of nickel titanium yellow, chromate titanate, manganese titanate browns are very, very popular. Then we have got metal oxides like iron oxides, chrome oxides. Then we have got some metal salts like chrome yellow. We have got different types of chrome yellow also, like lemon chrome, middle chrome, orange chrome, etc. Then we have got molybdenate orange, iron blues, and we have got other pigments like ultramarine blue, metallic pigments, carbon blacks. So these are all very popular synthetic compounds. And we have some phosphates also. Now let me explain one by one. Let me talk about these natural pigments. By its nature, after all, by its name, it's naturally available. They are all excavated from minerals. For example, this is yellow ochre, which gives yellow shades. And we can make use of different yellow shades by making use of different pigments obtained from different locations. Their tonal variations are very useful for us to give more different colors. This is the yellow ochre from another location. You could have seen these two difference. The difference between these two types of yellow ochres obtained from different locations. Now this is darker and this is brighter. Then these in those days, these yellow ochres and iron oxide yellows were used in ceramics. Ceramic pots are very popular with these yellow oxides. Indians and the Chinese, they have expertised in coloring ceramic materials. Generally, inorganic pigments are heat resistant. And we have got ambra pigments. Then we have got a variety of German, Japanese, Chinese and Asians. They have expertised in this field actually. Now, ambra, which gives a beautiful coffee brown color. Now, in fact, that is several pigments have been used in olden days also. Hematites are iron-based pigments, and we have got magnetites. They have got the magnetic properties. These magnetic infused concrete pipes are very, very popular. Besides natural pigments, they are more synthetic and inorganic pigments. Now let us talk about metal oxides. Titanium dioxide is a major white pigment used in paint industries. Its brightness is something unique. Titanium dioxide pigment, they have got two types of crystal structures, rutile and anatase, TiO2, titanium dioxide. These rutiles have, they have got a better, that is opaqueness, that is hiding power than anatase. Of course, anatase type of titanium dioxide is used in water-based emulsion, distemper and wall paints. Whereas rutiles have got very good usage in good quality oil-based paints because they have got more hiding power than anatase, and its covering capacity is great. There are some properties of pigment. First of all, that is, it should give everlasting color, and it should have good hiding power, that is called opacity of the pigment. In fact, we can check the opacity of a red pigment like this. we can apply the paste of fixed quantity of pigment with the proper ratio of a particular resin or varnish or oil, and this can be applied on various surfaces. Thereby you can see the difference in the opacity. Of course, that is the good one will definitely hide. For instance, we have applied that is a white paint on the red surface, where you can see here it is totally opaque in the last case. Okay, so here it is almost transparent, so it means the hiding power is greater. So similarly, red pigment okay, so can be tried on the white surface. For instance, here we have tried the red pigment, so the opacity is superior here, is it not? And when it goes like this, when it is coated with a different opaqueness, you can see that is its hiding power is the least as the that is opacity goes down here. So it means that is its coverage is very poor when the opacity is the least. Then the red pigment totally covers the white surface. In the first case here, it is measured as 1.0. So it means it has got the fullest opacity. Opacity means hiding power. Now you can see the red becomes transparent slowly with fading also. So naturally, when the opacity goes off, it gets deteriorated also, and it may get fading very soon, and that is not a good pigment. Now let us talk about the dye. The dye gives color but does not give opacity, so that makes the difference. In fact, some people cheat coating inorganic with some artificial coloring dyes, but take care, by bleeding properties it can be easily found out. So there is one bleed test, that is with which we can easily find out the contamination with some rich dye, but it may easily fade off. And then that is pigment quality is very important in this case. So that is, let us talk about this titanium dioxide. Titanium dioxide, as I already explained, that is it has got the two crystalline nature, that is anatase and rutile. Rutile has got better opacity than anatase, and that is why rutile is used in superior quality paints, that is oil based paints, whereas anatase is more comfortable with that is emulsion type of paints. Besides, we use zinc oxide, zinc sulfide, lithophone also as white pigments. Now, as I already explained, there are some non-opaque, that is powders with less hiding power, and they act as extenders, like in the case of calcium carbonate, talc, barium sulfate, mica, silica, clays, etc. So they are all called false pigment, that is pseudo pigments. They appear white but do not hide the surface. Such powders are used as extenders in paints. They are just fillers to reduce the cost of the paint. The quantity of extender is more in case of primer and primer surfacer. And there are some iron oxide and chrome oxide pigments. They are synthetically made, that is with rich colors. For instance, chrome yellows are very popular. We have got lemon chrome, middle chrome, then scarlet chrome. We have got various colors, and these are all the different yellow pigments, okay, with the different orange tones, etc. Now, on the mass tone and reduced tone. So this is very important thing. I think that is we can discuss about this mass tone and reduced tone of a pigment. How to check this? This is one of the important characteristics of paint, so that we can evaluate, we can validate the quality of the pigment, particularly with the help of this mass tone and reduced tone. So I will explain about this two tests related to pigment to evaluate the quality of the pigment in the next video. Thank you very much for watching this video. Welcome, my dear friends. In today's technical session on the topic series Introduction on Paint Technology, I'll be explaining about the various types of pigments and how to test these pigments for its quality. As we already discussed in the previous session, we have pigment and the pseudopigment. Pseudopigments means false pigment, like china clay, then barium sulfate, calcium carbonate, mica, soapstone, etc. So these are all called extenders also, but they are not true pigments. But when we talk about true pigments, we have white pigments and colored pigments. It can also be classified as inorganic pigment and organic pigment. Now let us discuss in detail. We are already familiar with some pigments like titanium dioxide, zinc oxide, zinc sulfide, lithophone, etc. And we know something about the chrome pigments. Now, let us see the iron oxide and the chrome oxide pigments. They are also available as a synthetic pigment. They are made rich in color. We have got chrome pigments. These are all yellow chromes. This is lemon chrome. This is middle chrome. Middle chrome will be orangish or reddish, whereas lemon chrome is greenish. And we have other type of a lemon chrome that is also much greenish one. So this is chrome, this is middle chrome, this is lemon chrome. And we have plenty of chromes, like that is we have got the primary color as well as the reduced color. Reduced color means that is its depth is somewhat low, that is it is something like a pastel or light shade. So we have middle chrome, light chrome, deep yellow, lemon chrome yellow, and we have orange chrome, zinc chrome. Then we have got various molybdenum, red chrome. Then we have molybdenum, red chrome 207. So you can find some tonal variation based on the grades. So likewise we have different types of chromes. And you can see on the right side they are mixed with white so that they are available as reduced tone. Then we have to check two important parameters as soon as you receive the material in bulk. The main thing is mass tone and reduced tone. The mass tone is nothing but we have to make it as a paste with the required amount of oil, like we can make use of this linseed oil or any other semi-drying oil. So you take a pinch of quantity, a small quantity of pigment and small quantity of semi-drying oil, that is the linseed oil, and make it into a paste. It should have somewhat like a buttery consistency. Now we can either make use of the hand muller or that is electrical pigment muller. This is the electrical pigment muller, and we can make use of the glass paperweight also, and that can be ground on either a granite or that is a ground glass slab. Now we have to make it as a paste and apply on a glass slide so that we can match the color. Okay, so this is the first one, mass tone. Reduced tone means you have to mix it with white, especially titanium dioxide rutile. So in the required ratio, for example, 1:10 or 1:20, okay, so based on that, you can check along with your standard so that the tinting strength can be evaluated based on this. So this mass tone and reduced tone are the two important parameters we need to check so that we can have some good idea about the pigment and its tinctorial or tinting strength, that is coloring strength. And then we need to arrive at the proper pigment binder ratio, and for which you have to select the appropriate binder, in this case the resin. So the selection of resin is also very significant. Okay, so you can go through a book written by Turner. It's a very good book. It's available in Google and Amazon also, so you can check it. And this is the title is Introduction to Paint Chemistry and the Principles of Paint Technology by G.P.A. Turner. So this is one of the best books I can recommend if you want to have better understanding about the chemistry of paint. Now, as I already discussed, see, that is either you should have a ground glass slab or granite stone. So it can be of a 3 feet by 2 feet size. So over which you can make use of, that is you need to have such kind of a doctor's blade with which you can make it as a paste. The pigment can be made into a paste. So this is called mass tone, and this is the reduced tone, and this is also called a tint tone. So you can take, that is a small amount of fixed amount of a pigment and grind it into a paste using the linseed oil, so that you can apply this as a paste on the that is either on the glass plate, or you have got the tinting chart also, so over which you can apply, so that you can simultaneously check the hiding capacity, hiding power or opacity of the pigment. Anyway, so this mass tone and reduced tone, as I already explained, that is it is mixed with titanium dioxide rutile to the fixed ratio like 1:10, and we check the color strength also. Okay, right. And now this is the mass tone chart, where you can find this is the standard, and suppose the material which is supplied as a bulk one may be having some slight difference in the tonal variation, and that can be immediately, that is evaluated, or it can be given as a remark saying that in this case this is the standard and this is the bulk supply, that is the supply sample. So this is less reddish. So this is the way you can interpret the mass tone either. And as far as assuming that the right is standard, left is supply, means you can say this is dirty or reddish. Okay, so likewise you should be able to interpret the color, and not only that, you can find the opaqueness of the pigment by applying on a black strip. Okay, so that you can find out. Now you can see this is transparent, whereas this is translucent, whereas this is opaque, that is it has hidden the black surface. So based on that, we can distinguish the opacity, that is hiding power of the pigment. Okay, right. So opacity means hiding power of a pigment. When you have got the least opacity, it represents more transparency. It means this may not be a good parameter as far as pigment for paint is concerned. Okay, so for a true pigment, it should have best opacity or the hiding power. Now, dye is something, it is transparent. The process of dyeing is totally different from painting. So dyeing is the interfacial coloring, that is it penetrates into the substrate, whereas a paint is applied on the surface, so where the hiding or the opacity is very important. Right. Now let us consider that is there are some essential pigment properties like that is you have to check the color, mass tone, reduced tone, then opacity, and then color strength. Then light fastness can also be found out, whether the pigment can withstand maximum exposure and a longer duration to the sunlight. So all these things are practically examined. Light fastness and weather resistance means that is how far it can withstand to extreme weather conditions. Okay. Then heat resistance, then insolubility, because pigment is supposed to be inert. It should not be chemically inert, chemically reactive. So it should be inert, and especially it should not be soluble in water and in any major petrochemical solvent, particularly xylene. Then we have to check other chemical resistance, and the price should also be matched. So we had to compare like this. Then now let us compare the inorganic and organic pigment. Inorganic pigment has very good hiding power, whereas organic may have less hiding power. Okay. And particularly when the light, let us consider irrespective of the inorganic or organic, when a pigment has lower hiding power, what could be the result? It means when light falls on the pigment, it does not reach the deeper in case of a good pigment. If it is not having hiding power, then definitely it will have the transparency. Okay, so that will affect the stability of the pigment also. Now you can see in the case of dye, it is so transparent, and in case of paint, it is opaque. So opaqueness is much recommended in the pigment that is used in paint. Okay, whereas the dyes are more transparent, is it not? Right. Then now let us talk about the varnish. Pigment plus varnish is equal to paint. That is, paint is nothing but pigmented varnish. Suppose if you remove the pigment from the paint, then it acts as varnish only. So varnish is nothing but resin, some additives, and some diluent along with some thinner. Okay, so it's also called a clear. So especially on wood we apply varnish or wooden lacquer. And see, the stains are very, very important here. In fact, the wooden stains are the natural beauty, so it should be transparent and it should be visible. So these are all the different coating thickness of varnish, so that you can have different depth of colors also. Okay, so we've got various types of varnishes. Okay, right. So far we have discussed about mass tone, reduced tone, and we need to discuss about the texture based on the C residue analysis, and we'll be discussing about oil absorption also as far as pigment is concerned. Okay, so we will continue this in the next session. Thank you for watching this video. 100 means finer, 500 means much finer, 600 means much more finer. So with the increase of seed size, the particle fineness increases, and you can look at this from this graph. So with the increase of seed size, you can find the degree of what the perfect fineness will be increasing. And now we should talk about the C residue analysis and oil absorption. So these are all the various filters with the different mesh sizes. And in fact, this distribution of particle size is quantitatively determined by performing the mechanical analysis, which is called the particle size analysis. It is carried out in two parts: sieve analysis and sedimentation analysis. The distribution of gravel and sand particles is determined by the sieve analysis, and that of the silt and the day by silt and clay by sedimentation analysis. Now the particles are uniformly distributed, and this is done by ROS, that is residue on sieve. And we have to check whether the particles are of a uniform size, and that can be tested by using this technique called sieve residue analysis. Most of the natural pigments have different particle sizes, so we may not have uniform size. So the normal particle size should be 63 micron for paint industries when we get the pigments as raw materials. And micronized are available in 32 microns. They are called micronized pigments. So finer the particle size, greater will be the surface area. Now let us try to analyze this. For example, we have got this cube. Let me assume the side of a cube is 2 centimeter. We know it has got 6 surfaces, that is 6 squares. So lateral 4 and top and bottom each one. So totally 6 surfaces. So let us calculate the surface of this cube. We know the formula, the total area is 6a squared. So 6 into a into a, it means we have got 6 into 2 into 2, that is 24 square centimeter, that is the total surface area, right? And let me break this into, that is 8 cubes, that is I am equally dividing at all sides. So we are able to get 8 cubes. Now let us calculate, and the size of each cube, the side of each cube is 1 centimeter, right? And we have got 8 pieces. Now what about the surface area? It has increased to 48 square centimeter. How? Because for 1 cube, 8 surfaces, 8 into 1. Likewise, we have got for 1 cube we have got 6 surfaces. Likewise, we have got 8 surfaces. So 8 into 6, 48. So you look at this, the one which was originally with the cube with the size 2 centimeter has got 24 centimeter. But when it is divided into 8 small cubes, it has increased to 48. So by dividing equally, we are almost doubling the surfaces. From 24 to we have achieved 48 square centimeter. It means by reducing the particle size, we are increasing the total surface area. So in that case, the problem of wetting will be there when we reduce the particle size, and that is why we introduce this term called that is oil absorption. Oil absorption, as I already mentioned, finer the particle size, greater is the absorption of oil. So this oil absorption is an important phenomenon in deciding the glossiness of a paint. We decide the pigment binder ratio in a paint. So based on this pigment surface area, we need to calculate the amount of pigment to make a particular paint. For instance, it's applicable for both pigment and extenders also. So let us have a pinch of paint, a weighed quantity of pigment. Let us add slowly this oil. It can be a linseed oil, and when we make this into a paste, okay, so we have to just wet the pigment surface, okay. And what is the quantity of oil required for just to make it wetting of that particular pigment? That is called oil absorption, okay. So finer the particle size, greater will be the oil absorption. For example, let us have the pigment filler ratio. So here oil absorption intake and water absorption intake, so it varies based on the type of pigment. For calcinated kaolin, it is a 45, and WI, that is water absorption index, is 48. Now let me focus on oil absorption. For talcum 30, for calcium carbonate it is 19. You just look at it. So talcum is much finer than calcium carbonate. Then titanium dioxide, it is just 25 for us. Black iron oxide is only 16. It means that is the black iron oxide has lower value than that of the yellow iron oxide, which is 35. So likewise, we have various colors. You just check it up, this ultramarine blue, it has got only 16. So oil absorption index and water absorption index, it may vary with, that is material to material, that is pigment to pigment. Now, I hope that is for water-based compounds, that is water-based formulation, paint formulation, this water absorption index is very important. And for oil based paints, this oil absorption index is very important, and that decides the sheenness or matteness or glossiness of the paint, right? And here, when we talk about the pigment volume concentration, you should be aware of these two important parameters. One is called PVC, another is called CPVC, that is critical pigment volume concentration. So pigment volume concentration is nothing but the ratio between the pigment volume, that is volume of the pigment, and the sum of volume of pigment and volume of resin. So here, the critical pigment volume concentration is also another important parameter, and it is the point at which the right amount of binder is present, which can soak all the pigment particles and fill the existing gaps. For instance, suppose if PVC is less than CPVC, that is critical pigment volume concentration, it indicates that the pigment portion is less, binder is more. So naturally you can say it will be glossy. And when the pigment volume concentration is almost equal to this one, that is, it will be normal one. When pigment volume concentration is exceeding the critical volume concentration, there is a tendency towards the matteness. So it decides, this pigment volume concentration decides the glossiness of the pigment. Okay, so I hope that is you would have gone through these different parameters about the pigment, and in the next session we will continue the remaining topic. Thank you for watching this video. Hi friends, இன்னைக்கு நம்ம பெயிண்ட் இண்டஸ்ட்ரீஸில் ரெசினோட பார்ட், ரெசின் அப்படின்னாலே பாலிமர், அதனுடைய பார்ட்டை பற்றி பார்ப்போம். ஆக்சுவலி ரெசின் மேக்கிங் இஸ் த ஹார்ட் ஆஃப் த பெயிண்ட் இண்டஸ்ட்ரி. ஒரு நல்ல பெயிண்டோட குவாலிட்டியை தீர்மானம் பண்ணுறது எந்த பார்ட் அப்படின்னு பார்த்தீங்கன்னாக்கா ரெசின் தான். ரெசின் இஸ் நத்திங் பட் வார்னிஷ், சிம்பிளி ஸ்பீக்கிங் வார்னிஷ் அப்படின்னு சொல்லலாம். அதை கெமிக்கலாக சொல்லணுன்னா பாலிமர் அப்படின்னு சொல்லலாம். இந்த பாலிமர் பெயிண்டில் யூஸ் பண்ணுறதோட பர்பஸ் என்ன? பெயிண்ட் கேனில் இருக்கிறப்போ பெயிண்ட் லிக்விடாகவும், அதை வெளியில் கோட்டிங் பண்ணதுக்கப்புறம் ஏதாவது ஒரு சப்ஸ்ட்ரேட் மேலே கோட்டிங் பண்ணோன்னே அது என்ன ஆயிடுது? அது ஒரு ஃபில்மாகவும் மாறுது. அந்த ஃபில்ம் இந்த சப்ஸ்ட்ரேட் மேலே நல்ல பிடிமானமாக இருக்குது, அதை தான் அடேஷன் அப்படின்னு சொல்லுவோம். ஸோ இந்த அடேஷன் அதோடு இல்லாமல் இந்த லிக்விட் பெயிண்ட்டாக இருக்கிறப்போ அது லீனியர் பாலிமராக இருக்குது. சின்ன சின்ன அப்படியே ஒரு துண்டு துண்டாக நீளமாக இருக்கும் அதோடைய மாலிகுல் லெவலில் பார்த்தோம்னா, அதாவது ரெசினஸ் மெட்டீரியல், அதாவது பாலிமர் ஆஸ் அ ஹோல் பெயிண்ட் அப்படின்னு சொல்லலாம். அதுவே அடித்ததுக்கப்புறம் ஒரு ஃபில்ம் ஃபார்மேஷன் ஏன் வருது அப்படின்னா, சப்போஸ் அது வந்து ஆக்சிஜன் மூலியமாக ட்ரை ஆகுது. இட்ஸ் கால்ட் ஆக்சிடேட்டிவ் ட்ரையிங் அப்படின்னு சொல்லுவோம். அப்போ அந்த ஆக்சிஜன் மாலிகுல்லாம் ட்ராப் பண்ணோன்னே கிராஸ் லிங்க்டு பாலிமராக மாறிடுது. அப்போ பெயிண்ட்டோட ட்ரையிங் மெக்கானிசம் அப்படின்னு பார்த்தீங்கனாலே லீனியர் பாலிமர், லிக்விட் லெவலில் லீனியர் பாலிமராக இருக்கிறது ஃபில்மாக மாறுறப்போ அது கிராஸ் லிங்க்டு பாலிமராக மாறுது. இந்த கிராஸ் லிங்க்டு பாலிமர் ஒன்றோட ஒன்று நல்ல அடேஷன், கொஹஷன் இருக்கணும். அதாவது இன்டர்மாலிகுலர் ஃபோர்ஸ் வந்து நல்ல பக்கா பைண்டிங் இருக்கணும். அதோடு இல்லாமல் எந்த சர்ஃபேஸ் மேலே நாம் பெயிண்ட் அடிக்கிறோமோ அது மேலேயும் பைண்டிங் இருக்கணும். அதை தான் அடேஷன் அப்படிம்போம். ஆக்சுவலாக தேர் ஆர் 2 types ஆஃப் அட்ராக்டிவ் ஃபோர்ஸஸ் இந்த இடத்துல. ஒன்று வந்து இந்த பெயிண்ட் ஃபில்மு சப்ஸ்ட்ரேட் மேலே நல்ல ஸ்ட்ராங்காக அடேஷன் ஆகணும். இன்னொன்று தனக்குத்தானே ஒன்றோட ஒன்று பிணைப்பாக இருக்கணும். அது வந்து கொஹஷன் அப்படிம்பாங்க. ஸோ இந்த கொஹஷன் அண்ட் அடேஷன், இந்த ரெண்டுத்துக்கு டிஃப்ரென்ஸ் என்ன அப்படின்னா, கொஹஷன் அப்படிங்கிறது இன்டர்மாலிகுலர் ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன், தனக்குத்தானே மாலிகுல் ஒன்றோட ஒன்று ஒரு பிணைப்பை ஏற்படுத்திக்கிறது. அது மூலியமாக ஒரு கிராஸ் லிங்கு. ஒன்ஸ் கிராஸ் லிங்க் ஆனோன்னே 2 விதமான சப்ஸ்ட்ரேட்டு, 2 டிஃப்ரெண்ட் சப்ஸ்ட்ரேட்டில் இந்த அட்ராக்ஷன் ஆகணும். அதுதான் அடேஷன் அப்படின்னு சொல்லுவோம். இப்போ நம்ம அடேசிவ், ஒட்டும் பசை, கம் எல்லாம் சொல்கிறோம்ல, அதே மாதிரி தான் ஒரு சப்ஸ்ட்ரேட் மேலே ஒரு கம்மா தடவினோம்னா இன்னொரு சப்ஸ்ட்ரேட்டு ஒட்டணும். ஸோ 2 டிஃப்ரெண்ட் சர்ஃபேஸில் ஒட்டிக்கிற நேச்சரை தான் அடேஷன் சொல்லுவோம். ஒரே சர்ஃபேஸில் இருக்கிறப்ப அதை கொஹஷன் சொல்லுவோம். இப்போ புரியுதுங்களா? ஸோ கொஹஷன், அடேஷன் இந்த ரெண்டுமே பெயிண்டோட முக்கியமான ப்ராப்பர்ட்டி. அது எது தீர்மானம் பண்ணுது அப்படின்னா இந்த ரெசின் தான். ஸோ அதனால தான் பெயிண்ட் பண்ணுறப்போ இந்த ரெசினோட குவாலிட்டி வந்து ரொம்ப ரொம்ப முக்கியமானது. இப்போ இந்த ரெசினோட கண்டென்ட்டு ரொம்ப கம்மியாக இருந்தது அப்படின்னா, ரொம்ப ரொம்ப கம்மி அப்படின்னா அது வந்து ஒரு மேட் ஃபினிஷை கொடுத்துரும். கொஞ்சம் ஜாஸ்தியாக இருக்குது, ஒரு அரவுண்டு ஒரு 30% ஒரு செமி மேட் மாதிரி வரும். செமி கிளாஸின்னு சொல்லலாம், ஒரு 40-35 ரேஞ்சில். அப்புறம் ரெசினோட பர்சன்டேஜ் ஆல்மோஸ்ட் 50% கிட்ட வந்துடுச்சு அப்படின்னா, இல்லை ஈவன் 55 அந்த ரேஞ்சில் இருந்தது அப்படின்னா, அந்த டயத்தில் என்னன்னாக்கா ஒரு நார்மலான கிளாஸி பெயிண்ட், அதுக்கப்புறம் சூப்பர் கிளாஸி பெயிண்ட், அதுக்கப்புறம் இன்னும் இன்க்ரீஸ் ஆச்சுன்னா அதான் பிக்மெண்ட்டே இல்லைன்னு அர்த்தம். அதுதான் என்னது? வார்னிஷ். ஸோ பிக்மெண்ட்டே இல்லாத ஒரு பெயிண்ட்டை என்ன சொல்லலாம்? வார்னிஷ்னு சொல்கிறோம். அதுதான் நாம் வுட் சர்ஃபேஸில் அடிக்கிறோம். இது ஏன் சார் மெட்டல் மேலே வார்னிஷ் அடிக்கிறது இல்லை? மெட்டல் மேலே வார்னிஷ் அடிக்கிறதுக்கு காரணம், அடிக்காததுக்கு காரணம் என்னென்னா, அந்த மெட்டல் சர்ஃபேஸில் அப்படியே தெரியும். ஆனால் இப்போ அது அடிக்கிறாங்க, வார்னிஷ்னு சொல்கிறதில்ல, நம்ம அதை கிளியர் கோட்டுன்னு சொல்கிறோம். இந்த வுட்டன் ஃபினிஷுக்கெல்லாம் வார்னிஷ்னு சொல்கிறோம். அது வந்து பிக்மெண்ட்லெஸ் பெயிண்ட் அப்படின்னு சொல்லலாம். ஸோ அந்த வுட்டு மேலே அடிக்கிறப்போ அந்த வுட்டோட நேச்சுரல் ஸ்ட்ரெயின்ஸ்லாம் தெரியணும், அதோட பேட்டர்ன்ஸ்லாம் தெரியணுன்றதுக்காக தான் இந்த மாதிரி டிரான்ஸ்பரண்ட்டான வார்னிஷை நம்ம பண்ணுறோம். இப்போ ஒரு நல்ல டீக் வுட் வாங்கி அதில் சாலிட் பெயிண்ட் அடித்தோம்னா அதை போல் கேவலம் எதுவுமே கிடையாது. ஸோ நாம் அந்த பெயிண்ட்டோட வுடன் கிரெயின்ஸ், அதோட பேட்டர்ன், அதோட டிசைன், அந்த டீக்கோட பேட்டர்ன்ஸ்லாம் தெரியணுன்னா அருமையான ஒரு கிளியர் கோட்டு தான் அடிக்கணும், வார்னிஷ் தான் அடிக்கணும். அந்த வார்னிஷை ஸ்ட்ரைட்டாக அடிச்சிடலாமோ? அடிக்க முடியாது. ஸோ அந்த இடத்துல ஒரு டிரான்ஸ்பரண்ட்டாக இருக்கணும், அதே டயத்தில் சர்ஃபேஸை ஈவனாக ஃபில்அப் பண்ணணுன்றதுக்காக நம்ம சாண்டிங் சீலர் அப்படின்னு சொல்லிட்டு இந்த வுடன் ஃபினிஷுக்கெலாம் கொடுப்போம். அது டிரான்ஸ்பரண்ட்டாக ஒரு டிரான்ஸ்லூசண்ட்டாக இருக்கும். ஸோ தட் அந்த ஹெல்த்தி வுடன் லுக்கை அருமையாக அப்படியே ரிச் லுக்கை எடுத்துகிட்டு வரும். அது மேலே நம்ம வார்னிஷ் அடித்தோம் அப்படின்னா அந்த வார்னிஷ் உரிகிற தன்மை கம்மியாக இருக்கும், கிளாஸினஸ் பெட்டராக இருக்கும், கவரேஜ் பெட்டராக இருக்கும். ஸோ அதனால தான் வுடன் ஃபினிஷ் அப்படிங்கிறப்போ ஒரு சாண்டிங் சீலர் அடிச்சுட்டு அதை வந்து சாண்ட் பண்ணிவிட்டு ஸ்மூத்தன் பண்ணிவிட்டு அதுக்கு மேலே நம்ம வார்னிஷ், அதாவது ரெசின் அப்ளை பண்ணோம்னா, கிளியர் கோட் அப்ளை பண்ணோம்னா சிறப்பாக இருக்கும். ஆனால் வுட்டில் அடிக்கிறப்ப சாலிட் பெயிண்ட் அடிக்கணும். சில டயத்தில் இப்போ காப்பர் இருக்குதுன்னு வச்சுக்கோங்களேன், அந்த காப்பரில் என்ன பண்ணலாம்? நல்லா பளபளன்னு சுத்தமாக அதை க்ளீன் பண்ணிவிட்டு நல்லா அது வந்து அடேஷன் இருக்கணும், அது ரொம்ப முக்கியம். ஸோ அந்த பளபளப்பான ஒரு காப்பர் சர்ஃபேஸ் மேலே இப்போல்லாம் என்ன பண்ணுறாங்கன்னாக்கா PU கிளியர்லாம் கொடுக்குறாங்க. ஸோ இந்த மாதிரி PU கிளியர் கோட் கொடுத்தோம் அப்படின்னா அந்த காப்பர் ஒரிஜினல் லுக்கு அப்படியே இருக்கும். இப்போ ஒரு நிறைய நாங்கள் கூட ட்ரை பண்ணியிருக்கோம், இந்த கும்பம்னு சொல்கிறோம்ல ஆலயத்துக்கு மேலே. ஸோ அதில் கூட இந்த மாதிரி பாலியூரித்தேன் கோட் கிளியர் கொடுத்தோம்னா ரொம்ப பிரமாதமாக இருக்கும். ஆனால் அது வந்து பிளெமிஷ் ஆகாமல் இருக்கும். எப்போதுமே காப்பரை வந்து க்ளீன் பண்ணிவிட்டு 2 நாள் கழித்து பார்த்திங்கன்னா மறுபடியும் கருப்பாகிடும், அதாவது பச்சையாக ஒரு மாதிரி மாறிடும். ஆனால் இந்த மாதிரி கிளியர் கோட் அடிச்சிட்டோம்னாக்கா அது ரொம்ப நாளைக்கு, ரொம்ப வருஷத்துக்கு அப்படியே நிற்கும். ஸோ இந்த கோட்டிங்கை எப்படி அதில் நல்லா ஸ்ட்ராங்காக அடேரன்ஸ் பண்ண வைக்கிறது, ஒட்ட வைக்கிறது, அங்கே தான் ஒரு சில முக்கியமான வேதிப்பொருட்கள்லாம் நம்ம சேர்க்க வேண்டியிருக்கு. ஸோ அதை பற்றி அடுத்த லெக்சரில் நம்ம பார்ப்போம். Hi friends, welcome to my technical series on surface coatings. So in this session I'll be explaining about the coating performance and how to select a particular coating. There is a great word in Tamil regarding the purification of food. உணவின் தரம் என்பது 3 வகைப்பட்டது. பாக சுத்தி, பதார்த்த சுத்தி, பாத்திர சுத்தி. That is, if you expect a good quality food, first of all, the process of food should be of high standards, high quality. It should be very pure. And it also depends on the performance of the cook. Then it depends on the purification or the quality of materials we use in the food preparation. Then it also depends on the quality of the container in which the food is stuffed. Similarly, the quality of coating is also dependent on the formulation of that particular type of coating, then the raw materials used in that paint or finish or coating chemical, and how it is packed. That is also important. The container is very important. It takes a very significant role in paint industries. Then how it is stored and processing, then how it is applied at the customer's end, and with all that, the customer should have the complete awareness about the usage of the paints. Let me explain about the metal finishing here. Here, it depends on the quality of component. It depends on the design of the component. Then metal pre-treatment, what kind of pre-treatment we are going to give before coating, and what is the nature of the first coat followed by the top coat. So let me explain one by one. Here, as far as the sheet metal is concerned, we got two types of metal, ferrous and non-ferrous, iron based and other metals like aluminium, galvanized iron, copper, brass, bronze. In fact, we can put this under ferrous also, GI, galvanized, because there will be a zinc coat over the iron sheet. Then we have under ferrous cast iron, mild steel, stainless steel, and we have got different types of stainless steel like 224, 316, etc. Then, in fact, we need to justify first of all what type of coating will withstand over which type of metal. So this is very, very important. Then, as far as the design part is concerned, that is, it should not have sharp edge, because according to the physics of action of points, there will be more charge accumulated on sharp edges, so that the material will have greater tendency for rusting or oxidation or preferential electrochemical corrosion. And that is why most of the designs are nowadays of curved nature, curved surface, so that we will have lower extent of corrosion. Instead of designing a Jeep like this, you can think of having a shape like this, a curved one. Why? Because in this sharp edge, in fact, the coating thickness will also vary. Let me say in sharp edge, we are given the coating like this, and here we have given the same coating, but the problem is you will not achieve the coating here, the required coating here. So there is a chance of penetration of any detrimental elements through this lower DFT, that is dry film thickness. And that is why if you coat like this, it will be uniform, so the coating thickness will also be uniform. That is why people nowadays prefer curved surface, and it should be free from silent corners. So the design engineer should take care of these aspects. Then try to reduce the welded area. We cannot simply avoid the welding, but that is try to minimize that. And you should have a specialty coating for the welded portions, because that will trigger the electrochemical corrosion at that particular point. You could have seen such type of rust preferentially taking place on the welded portions. Then, as I already mentioned, if it has two different components, then you have to make it sure that they should have the same property or similar property. Suppose if it is a stoving enamel, it's of a different specific resistance means probably the extent of curing will be different as far as thermosetting acrylic paints or any stoving epoxy or stoving enamel paints are concerned, because the absorption of heat will be different based on the specific heat capacity of that particular material. Then here as far as the pre-treatment is concerned, because you may be having very top quality paint, but unfortunately if it's not prepared properly, then it is of waste. So you have to give a better metal pre-treatment. Either you can go for zinc phosphating, or you can go for nano ceramic coating, and sometimes some people prefer self-etch priming, as in the case of non-ferrous metal. In fact, we give consultancy services for all these kinds of metal treatment, pre-treatment. And then the top coat. As far as top coat is concerned, some people prefer liquid paint, and most of them nowadays prefer powder coated system. Under liquid paint, you have stoving enamel, stoving epoxy, thermosetting, acrylic. All these three are heat cured, that is, it can be cured only at higher temperatures. And we have got some low bake enamels also. Nowadays, some accelerated curing along with hardener packed items like polyurethanes also available. And we have two pack system like epoxy amine and epoxy amide. And over that, some people give glaze coat, that is top coat, top clear coat. It's called a glaze coat. So that, and here the mark proofness, that is, it should be scratch proof. So in order to have a better aesthetic value, this kind of paints, or the clear coats are given nowadays. And then as I have already explained, in powder coat we have got different systems like urethane, epoxy, and epoxy amide, polyester, etc. Then the purpose of coating. Here we should understand for what purpose you are going to give the metal finishing for your component. For example, whether you are very specific about anti-corrosion or weatherproofness or waterproofness or chemical resistance or heat resistance, and with all that you had to specify whether it is food grade or commercial grade. So these are all very, very important. And as far as salt spray is concerned, that is anti-corrosion nature is concerned, that is you have to fix the number of salt spray resistance hours in terms of 240 hours, whether you require like this. You have to discuss with your customer actually. So whether it is for 240 hours or 400 hours or 600 hours or 1000 hours, etc. Okay, so based on the salt spray resistance, we have different types of chemical constitutions of coatings. Then you have to maintain these standards like Bureau of Indian Standards. This is our Indian standard, and some people, based on the customer, they have to adhere to this British standard, and some companies they insist for ASTM, that is American Standard Testing Methods, and if it is a Japanese company they will insist for Japanese Industrial Standards, JIS. Then there are some DIN specifications for German based companies, and we have sometimes international standard organization, they may insist for ISO standards. Similarly, we have to be very careful when we select our suppliers. You have to check whether they have complete technical know-how for the proposed project, and with whom they have collaborated, and what are the standards they are maintaining, what are their internal standards, and what are the internal standards you can develop along with their, with your suppliers. Then consistency of their supply, then technical competency, and what way that is that they can cooperate with us. All these things should be taken care of when you select any supplier. And then internal standards. As far as internal standards are concerned, that is, your raw materials are very, very important in determining the quality of your end product. So you should have stringent raw material specifications, and you should have developed internal standards. And for process also, you should maintain standard operating procedure. Then you should have a firm quality policy, and better you can have some training for quality circle activities, so that it will improve the team performance and good working culture. Then you should adopt the statistical quality control. Then there should be regular training. And then you should treat the next stage operator as your internal customer. So these are the internal customers. So within the processing cycle, you must support. Then, as I already mentioned, with all this, you can achieve the end quality, the end product quality. And with all that, even after the sales, that is, you should try to get the customer feedback. And after getting the customer feedback, if there is any complaint, we have to maintain the complaint investigation report. And then you should have a total dedicated after sales technical service team. Then you should have a regular consultancy, so that he'll be acting as your internal guru. In fact, I am very interested to collaborate with your organization as your mentor, as your guru, as a consultant. If you have got any requirement, you can contact me. Thank you very much. Friends, this is one of the important technical series in coating technology. In this session, I'd like to talk about waterborne coatings. You know something about emulsion. For example, oil and water, these two are totally immiscible liquids. When they are made to miscible, it needs an emulsifier, that is the bridging agent. Because water is totally aqueous, that is polar system, oil is non-polar system. So in order to make these two incompatible liquids to be miscible, we need a specific agent like soap, or that is detergent, or emulsifier, which has both tendencies like that is polar tail and non-polar non-polar tails and polar heads. Non-polar tail means that is it has a long chain, that is a fatty acid group, like that is alkyl group, we can say long chain as alkyl group. It can even cross C17, C18, etc. Like CH2, 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 CH2. So there is a long chain of carbon and hydrogen atoms. So that is called the non-polar tail portion of the emulsifier. And polar head is water soluble portion, like carboxylic acid, or in the case of base, it can be that is a tetraalkyl ammonium, etc. Now, the idea behind adding this emulsifier to the two immiscible liquids is to make them as a resultant solution, that is called emulsion. And this emulsion is also known as latex. This latex emulsion, it has got the larger particle size. Its size is greater than actually 0.6 micron. 1 micron is 10 power minus 6 meter. And the molecular weight will be tentatively greater than 10 power 6 per mole. And these are all the either it can be a resin dispersion or resin aqueous dispersions. Generally, they are milky white, and its opacity is there. I think that is opaqueness. Opaqueness means that is it doesn't give any transparent film. Whereas when you talk about colloidal dispersion, this is water solubilized one. So water solubilized colloidal dispersion, where the water dispersible resins are present. It is slightly hazy and translucent. and the particle size will be smaller. It is less than 0.1 micron, and the molecular weight is in the range of 2 into 10 power 4 per mole from 2 into 10 power 5 per mole. So this is known as the actual colloidal dispersion. Here we have got different terminology when we use these latex paints containing water soluble binders. Some call them waterborne coatings, some call them water based coating, and some of them call water reducible coatings and water soluble coatings. So likewise it has got various terms. When we talk about the performance of such kind of waterborne coatings, the lower levels of carboxylic acid present in that formulation will have better salt spray resistance, but at the same time it has got poor solubility also. So we must arrive at an equilibrium between this, because it will result some application issues also when you reduce the carboxylic acid content. But when you increase, it will affect the salt spray resistance. And similarly, it may, there are various types of systems in these waterborne coatings. Like we have, apart from the air drying waterborne coatings, we have thermosetting waterborne coatings, then ED coating, that is electrode deposition coatings. Here, the important cross linkers are used in this case. For example, hexamethylene, methylamine, and similarly, we have, we had to add a small amount of a para-toluene sulfonic acid as catalyst, because it will activate that is releasing also. So these are all the key parts of formulating such type of waterborne coatings. And there will be an impact in the viscosity during the dilution of waterborne coatings. What is that? For instance, the higher water co-solvent ratio, because of the increase in the water, it will definitely affect the hydrophilic interaction. Hydrophilic interaction means that is the groups which have the tendency to attract water part. So hydrophilic interaction. And similarly, it will have a greater impact on polyion expansion and micelle formation also. Let us look at this graph here. See, that is with the increase of percentage of solids as well as organic solvent base is concerned. When we talk about this ratio, it will prolong like this. Whereas in the case of water-based coating, there will be an increase and it attains the maximum, and again it finds a dip. So you need to mark that plateau, that is the maximum point. So while you formulate such type of coatings, you have to take care of the viscosity variation also, because it will drastically affect when it is diluted with water. Then let us talk about this micelle formation. Here, the low molecular weight resins, that is without affecting the film properties, so that will not affect the micelle. At the same time, we can increase the co-solvent content also. Similarly, that is, we can increase the carboxylic acid contents, but make sure that it will not affect the application aspects. And this, simultaneously, you had to use some co-solvent, but preferably with long alkyl group. That is very, very important. And when we talk about this co-solvent, make sure that it should be more rapidly evaporating than water, because it has to maintain a good leveling and anti-sagging. Otherwise, the paint will run down and it will have a lot of fissures problems also. So you have to be very careful in formulating by incorporating these co-solvents. And similarly, higher levels of solubilizing groups result, poor salt spray resistance. So there must be some balance between them. And I will talk about this pigment volume concentration, the role of PVC and the CPVC in the formulations, and that will affect the paint performance in my next lecture. So thank you very much for patiently listening to my video. If you've got any formulation guidelines, you can contact me in this email address. Thank you. Hi, my dear students. Today I'll be discussing about the chemistry of corrosion. Corrosion is the biggest issue in Indian economy, not only in Indian economy, the global economy. Here, the corrosion is nothing but rusting, that is, the oxide film formation on a metal, that is called rusting. In the case of iron, you are able to get that red rusts, and in the case of copper, green rusts. In the case of aluminium, white rusts are formed. And in fact, almost metals are electropositive. Electropositive means they have the tendency to release the electron, and this release of electron is called the oxidation, that is removal of electron, de-electronation. So this is the natural tendency of any metal to undergo oxidation. So metal becomes a metal oxide by the aerial attack in presence of water. So air and water are the two important compounds required for the rust formation. So the metal undergoes oxidation to give metal oxide. As I already mentioned, water and air are the essential components of during the process of rusting, so that the metal becomes a metal oxide film. So once the metal becomes a metal oxide, its strength is weakened, the metal strength is weakened, and thereby it damages the structure, because it is the deposition of these rusts. It is something like a salt, is it not? Iron becomes iron salt, Fe2 plus. Okay, so that is why the structure is further weakened. Suppose if the bridge is made up of iron beams, if it is rusted, the bridge may at any time collapse. So how to prevent that? And before that, let us study the mechanism of this rusting. What is the chemistry behind that? So this is nothing but an electrochemical reaction, or you can call it redox reaction. That is, oxidation and reduction, they occur together. Here, when I say electrochemical reaction or corrosion, you should be able to identify the anodic site and cathodic site on the metal. Let us consider this is the iron bar or iron sheet metal or anything iron, like iron rod. So let me consider this iron base, where that is this iron base is exposed to water at one place and exposed to oxygen at another place, and there arises the electrochemical cell, because that is anode is the region of metal exposed to low oxygen content, that is it is enclosed by water. So that is why this portion is called anodic site, okay, or anode. And what about cathodic site? The cathodic site is the region of the metal where it has the high exposure of oxygen, that is there will be plenty of oxygen available, and therefore it acts as cathode. You should know one important thing: at anode oxidation occurs, at cathode reduction occurs. Okay, so I will explain about these redox reactions, okay, subsequently, right? Now let us talk about the electrochemical corrosion. So in electrochemical corrosion, we have already discussed that is the iron Fe, which is in the solid form as an electrode or metal. Okay, so it undergoes oxidation. At anode, oxidation takes place. So oxidation means a removal of electrons. So two electrons are removed here, and thereby it becomes the Fe2 plus. So this is the oxidation, and that occurs at anodic site of the metal. And at cathode, of course, its reduction potential is given as E naught is equal to, you can put E naught like the standard electrode potential of iron Fe2 plus Fe. This is the reduction potential. So its value is 0.44 volt. Okay. Now at cathode, reduction takes place. Reduction means electronation, that is addition of electron. So here oxygen as gas plus, and it may contain the H plus. Then electronation, that is addition of electron, so that it becomes what? That is H2O, that is water formation. H2O as liquid. Okay. Now we have to balance this. You can put a half O2. Now it is balanced. But this is the non-stoichiometric equation, that is not proportioned. So it should be converted into a stoichiometric equation so that you can multiply by 2. And moreover, you have got 2H plus because 2 and here 2 electrons. So 2H plus 2E it is, that is neutralized here so that you are able to get a neutral one, that is water. Now we have to multiply this equation by 2 so that 2 into half 1, that is O2 oxygen gas, plus 2 into 2 4H plus 2 into 2 4 electron, so that gives 2H2O. So this is the balanced equation for reduction. Okay, so and its value is found to be, that is the reduction potential of this oxygen to water. So it is given as 1.23 volt. Okay, so E0 for this reduction potential of oxygen. Okay, so that is O2. Okay, so that becomes what? H2O. Right, so this one is equal to 1.23 volt. Okay, 1.23 volt. Now let us compare the value of these two. From the value you can immediately say that which can undergo oxidation. In fact, this is the reduction potential. So lower the reduction potential, higher will be the tendency for oxidation. Now let us compare 1.23 and 0.44. So when you compare which is the lower reduction potential, that is iron 2 plus electrode potential, and therefore this acts as anode, and that is why now it is pretty clear that at anode iron becomes iron 2 plus. So this is given in terms of reduction potential. If you want to know the oxidation potential, what you have to do, change the sign so that it becomes minus 0.44 volt, and that is the oxidation potential. But by convention in India, we always interpret the electrochemical series, that is the table of standard electrode potential in reduction potential only. Okay, right. Now we have to combine these two equations. So when you combine these two equations, or how to proceed, now you have to strike out the electrons completely. You have got 4 electrons here, whereas you have got only 2 electrons. So what you are supposed to do, again you have to multiply by 2. So you can multiply by 2 once again, then it becomes what? 2O2 here, is it not? So you can put here, let me write here, because this is 4 electron, you have to multiply this equation by 2. So it becomes what? 2Fe, and this becomes 4. Okay, now it's balanced, right? Now this is by convention, anode should be written on the left side, cathode should be written on the right side. Okay, so this is the cathode, and by convention the formula is, that is cell EMF, because we can combine 2 electrode to get the cell, and the cell EMF, that is standard cell EMF, is equal to E right minus E left. Okay, standard potential kept at right side. So kept at right side means at the right side you have got the reduction potential. And what is the reduction potential here? This is how much? And in fact that is for iron, it is minus 0.44. Okay, so minus 0.44. Okay, because it is in the left side. Okay, so you have to put minus here. And what about cathode? Cathode is 1.23. So we have to do, first of all, let us combine these two equations. That is, let us consider this equation as 1 and this equation as 2. Combine these two equations so that you can eliminate 4 electrons. So eliminate 4 electrons. Now combine. So 2Fe plus O2 gas, and this is solid, plus 4H plus gas, that is 2Fe2 okay, 2Fe2, and what we have, 2H2 plus 2H2. So this is the combined equation. Are you able to follow? And you can put liquid, and this is in the aqueous form, right? Okay, so 2Fe solid plus oxygen as gas plus 4H plus in the aqueous medium, okay, and 2Fe2 plus in the aqueous medium plus 2 water as liquid. This is the cell reaction, that is electrochemical cell reaction of this corrosion setup, okay, right. And what could be its value? This is nothing but E right minus E left. This is the left electrode, this is the right electrode, so you can subtract this, so that now you have got right electrode is 1.23 minus of minus left electrode 0.44, okay, this is the reduction potential. Now you can get what, 1.67 volt. So this is the cell EMF of what, this electrochemical corrosion of iron. Are you able to follow? So this positive sign indicates that the reaction is spontaneous. So likewise we can talk about this electrochemical corrosion also, okay, right. Further, the reaction, that is Fe2 plus ions, Fe2 plus ions can react with oxygen in presence of H plus. So this is the reaction we have already achieved, that is Fe2 plus, and on further addition of oxygen it becomes what, in presence of H plus, okay, in presence of H plus, and this becomes Fe3 plus, okay, Fe3 plus, and with the removal of water, okay. Now you can balance this, you can put 2H2O because O2 and 4H plus, okay. Now here, that is you have got Fe2 plus, right, and you have 4 plus, okay. So 4 plus plus 2 plus, how much? That is 6. In fact, this is 4Fe, right, 4Fe, and this becomes 4Fe3 plus, okay. So 4Fe3, because we have to, that is balance the equation, okay. So Fe2 plus plus oxygen plus 4H plus, that gives 4Fe3 plus in aqueous form, that is aqueous, as aqueous solution, and this is as liquid, okay. Are you able to follow? Right. Now, and this is the ferrous ion, and this is ferric ion. So the virgin metal surface becomes Fe2 plus by the loss of 1 electron, 2 electron, and on further loss of 1 electron it becomes Fe3 plus. Are you able to follow? And this can become that is a hydrous oxide also, hydrous peroxide. For instance, here once in terms of oxygen, FeO, this is iron oxide, and this iron oxide becomes Fe2O3, that is ferric oxide. This is ferrous oxide, its oxidation state is +2, and here its oxidation state is +3, Fe2O3. And this can be in the hydrated form also, based on the number of water molecules trapped. So you can put hydrated, X moles of hydrated iron oxide, that is Fe2O3, ferric oxide, right. And in fact, this may be the red rust, and it can become a black rust, and it can further become a pitted corrosion also, a pitted corrosion, and now it can even become ferroferric oxide like Fe3O4, which is the combination of FeO plus Fe2O3, and it can have a hydrated form also like H2O, X moles of water. Okay, so thereby the hard structure of iron becomes weakened by the formation of deposition of rust, that is rust collection. Okay. Now let us discuss about the methods of prevention of metal corrosion. We can apply oil so that we can avoid rust formation. We can use rust preventive oil for this method, and we can use the greasing technique. You can apply simply grease, okay, so that you can avoid direct water contact. Then galvanizing technique, that is by applying zinc, and in fact zinc as the that is sacrificial protection. This method is called sacrificial protection, and zinc has the better oxidation potential than the iron. So by sacrificial protection, it protects the iron. Your example, you have got galvanized pipes, iron pipes, GI pipe, and then phosphating. So this is another technique by forming phosphate layer over the metal, and this can be followed by painting so that the performance of the paint will be superior. Otherwise, you can go for direct painting by applying some red oxide primer or zinc chromate primer, etc. And when I talk about paint, it can be either that is a liquid paint, or that is a powder coating also. So here we have got the before doing this phosphating, the surface should be very clean. So for metal cleaning, we can adopt sand blasting by physical operation. Otherwise, you can use alkaline degreasing or vapor degreasing. So alkaline degreasing is a water-based one, whereas vapor degreasing is organic one. And followed by, if there is any rust, that should be removed. So we can have de-rusting process. But all these process should be properly cleaned, and the virgin should be very, the metal should be, the virgin metal should be very, very clean, and it should be free from dusts, rusts, dust in any form or rust, and even grease or oil. So it should be totally free from all these extraneous matter, foreign matters, so that the metal can easily undergo the formation of phosphate layer, okay, so that it can have a better adherence of paint also when a paint is applied over phosphating. Otherwise, we can straight away do the painting also. Then zinc plating or electroplating. Then alloy, we can have, for instance, that is alloy coatings also. And passivation, by applying some oxidizing agent, you can further suppress the reactions. And cathodic protection, nowadays protection, like we have got the cataphoretic coating, ED coating we used to say, electrode deposition coating. So these are all very famous method to prevent the metal corrosion. So I hope you would have enjoyed this lecture, and we have got further details about that is the individual part, like sandblasting, how to do that, degreasing, alkaline degreasing, vapor degreasing, and how we can do the de-rusting operations, and what is phosphating and what is zinc plating. So these are all the various techniques we will be discussing further in my subsequent lectures. Thank you very much for watching this video. Welcome, my dear friends, to my technical series. Many of my friends they wanted to discuss on this topic. Sir, that is what kind of services you are providing, so that we will be very much interested to make use of your services in different ways. So for their requirements, it is my responsibility to share my experience and your requirements, in what way I will be helpful as well as a consultant is concerned. Okay. Now, see, that is my paint consultancy services. I have branched this into 10 types. For example, my responsibility is to give the global awareness about the paint making and the appropriate use of that is paint consumption, and particularly for metal finishing industries. Then that is I am doing these services through that is various social media, particularly in YouTube channel. That is I am promoting some of the important technical series also, so that everybody should understand. And I invite young entrepreneurs, engineers, even some of the guys who are very much interested, even though they are non-technical, but after seeing my lectures, they are very keen in getting some technical information. So it shows that to start a business, that is, it is not necessary that you should be an expert in that field, but with the help of some technical guru, it is feasible. Everything is feasible in this world. Okay, right. But the thing is, that is, you should acquire the technical knowledge with some guidelines. Okay, that is very important. Only thing is, you may ask me, some friends they ask me, some of my clients they ask me, sir, you have got you know something about paint and paint industry, paint making, and how to that is analyze the paint defects, and also advise suitable suggestions for automotive industries and other sectors. Then in that case, so why don't you start your own paint industry? Then I used to reply that you should have the basic confidence for starting the paint industry. Where that is, I am not bold enough because it is not possible. In fact, starting an industry is not everybody's cup of tea, is it not? So in that case, that is, you should have confidence, and then only you will be able to that is survive in this tough business field. So by virtue of my nature, I am fit. I know very well about myself, and I am fit for guidelines only. I am like a lamppost, so that my objective is to teach and to train the guys who are interested, so that they can actively participate, because we cannot that is get all types of works. Okay, so that is some people they are designed for that, and some people they are designed only for giving training to others, so that they will make them a successful one. So likewise, that is, I am only a ladder, so that I can support my young guys. Okay, right. Now here my objective is to create global awareness about the manufacturing of paint, either small scale or large scale, as well as what are the problems in that is handling the metal finishing products, and what are the possible defects. All these things I am giving in different social media, particularly YouTube channel. So the guys will be very useful, so that they will have some preliminary understanding about this subject. Okay, but just by going through YouTube's, it would be very difficult to say that they have achieved the that is technical competencies. So you have to go through various that is technical guidelines, technical books, references, and articles, and you should explore some more technical literature survey also in this regard. Okay, I am ready to help you in that is citing pertinent references for making of paint, analyzing the paint, and using the paint in various industries. Okay, right. Now, and we undertake, that is, I cannot myself take a project, but as a team, that is, I can undertake turnkey projects. So I have done various turnkey projects in powder coating, in metal finishing, in establishing the metal finishing workshops, paint shop, powder coating workshops, etc. Okay, and I have done some OEM people also. So you can go through my profile, so that you can understand about me in a better way. But my single objective is off late, that is nowadays, that is to promote youngsters in this wonderful field, because if you know the technology properly, and you are a protector, because as I used to say, paint is a wonderful product that can protect any surface and gives aesthetic value. And with all that, nowadays we talk about functional purposes of paint also. Now here, as I already told you, that is, I have got various engineers in during my course of industrial exposure and my business experience. I have got many people from different walks of life from the paint industries, and I know the best paint manufacturing, raw material resources, suppliers, intermediate suppliers, resin suppliers, and I know the somewhat the best quality, that is in manufacturers and machinery equipment suppliers, then additive suppliers, so that I'll be in a position to recommend. But once I introduce some guys means, it is up to you to have better business understanding in credits and debits. That is not my role, and I am least bothered about these commissions. I am not at all interested in any types of commissions for promoting anybody as a single entity. Okay, right. Now, paid formulation and training. So this is another scope where I focus engineers and graduates, so that even entrepreneurs, that is, they can formulate themselves. It is my idea, because I know various guys in this field have spoiled the reputation of some paint consultants just by taking formula from one industry or one company and selling to other people. So I am not the party for that. So in my opinion, as a consultant, as an experienced consultant, I would like to share my knowledge, so that I want everybody to, that is, understand and come out with their own formulation. So for them, I'll be very powerful guru. Okay, right. Now, machinery aspects. So as far as machineries are concerned, as I already mentioned, that is in paint industries, that is, you've got various that is machineries are required, and you should be able to that is identify the, that is the ideal resource persons or manufacturers locally or globally. But the technical service part is very important as far as paint manufacturing and equipments are concerned. Then coating defects. So this is another aspect in the perspective of what you call the paint making as well as paint users. So both of them are very important. I have seen many industries, and I visited many OEM manufacturers and that is engineering industries and automotive industries, where they are struggling for different types of coating defects, like peeling off, rusting, blistering, then adhesion, lack of adhesion, and chalking. So these are all the almost day-to-day problems encountered by the, and even by the industries, and even in the phosphate treatment and the nano treatment and the electroplating. So these are all the very that is pertinent problems, but we cannot say that it is a permanent one. There is a very good solution, but it is because of the human intervention that is some of the problems are not sorted out, because it is this world is something like a world of blame gaming, you know, that is nobody will understand and nobody will accept their fault. If we want to, that is pinpoint a person, definitely he will not accept his fault. So it is better to understand, to identify what has gone wrong, instead of identifying who has committed this mistake. So let us identify the defect of the process, defect or the method, so that we need not, that is have a conflict with the ego of any supplier or end consumer. For example, we have got the best car, but if you are unable to drive the car, you cannot simply blame the manufacturer. But at the same time, there will be some genuine defects also. So in that case, supplier, manufacturer, and end user, the customer, they should sit together and they should talk freely, and that too can happen in presence of technical persons, technical consultants like me, so that it should be very useful and you can arrive at some common understanding. Let us try to find out the solution, that is, so that it should not recur again. So we should have some standard operating procedure once it is established, means, because you can be totally trouble free also. Okay. Because you know very well, the product, the quality of the product depends on the quality of the raw material, how the raw materials are used, how they are stored. All these are very important. Okay, so we should arrive at a common SOP, so that even the labor should understand, the labor who is on the particular job should understand. Okay, it is not the managerial role only, it is not the responsibility of manager. It should be the responsibility. The quality work should be the basic or essential requirement of every part and parcel of this team. Okay, after is the teamwork. Now let me go to the next aspect, machinery. In the case of machinery, as I already explained, that is we are dealing with different type of machinery and coating defect. So here we need to arrive at a common that is SOP for analyzing the code and where it has gone wrong. All these things should be, because it can be from the manufacturer side or the end user side also. So you have to be carefully studying. Then raw materials, as far as the raw materials are concerned, that is we should be, I am able to identify good raw material resources, and even the product I can identify very good customers, so that you can sell your product also. Then materials, monuments. So as well as national monuments are concerned, with the help of wonderful, nowadays we have got smart and sophisticated coatings. With the help of such kind of coatings, I think that is government people also, they can come forward, so that we can provide wonderful conservation for our that is historical and classical and national monuments. Okay, right. Then paint testing support. I offer some paint testing support services with the help of my friend circle, so that they are also in need of some basic work, and I can identify some genuine technical persons, so that they will be able to, that is do your testing services properly under my guidances. And metal pre-treatment is another part. Apart from the paint formulation, metal treatment is also very important, pre-treatment. So we have got different types of phosphating and nano zirconia coating. So for all these things, my consultancy services will be more beneficial to you. And with all that, sir, once I have established the paint industry, then what about the environment and pollution? So that is a very, very important point. So the safety and the environment are very important of any paint manufacturer. In that case, effluent treatment is a very essential part, and the safety and fire hazards. So these are all the very key area as far as paint is concerned. After all, paint consists of highly inflammable materials, so that we have to be very cautious about the handling and the storage of paint. So in documentations also, my services will be useful, like a material safety data sheet and product data sheets. So for all these is for document purpose, for developing new products, I think my technical services, and with the help of my young guys, the team of young guys, I'll be able to helpful to you. Okay, so thank you very much for watching this video. Developing new products, I think my technical services, and with the help of my young guys, the team of young guys, I'll be able to helpful to you. Okay, so thank you very much for watching this video. Developing new products, I think my technical services, and with the help of my young guys, the team of young guys, I'll be able to helpful to you. Okay, so thank you very much for watching this video. Developing new products, I think my technical services, and with the help of my young guys, the team of young guys, I'll be able to helpful to you. Okay, so thank you very much for watching this video.